I want to invite our first speaker now, Goran Milovanovic, a lead data scientist and manager at Smart Octo. Goran also specialized in decision theory, categorization, semantics, and so on. He successfully managed everything in the fields of AI and ML projects. He focuses on predictive analytics and recommendation systems in the digital media landscape. Goran is also the driving force behind Data Collective, a consultancy providing comprehensive data science services. His rich academic portfolio includes co-editing and co-authoring 5 books, numerous journal papers, and conference proceedings. With over 2 decades of experience, Goran is not only an industry leader, but also the founder and president of Machinery, a distinguished Serbian association in the field of AI, artificial intelligence, and machine learning. Goran, can you hear us?
Yes, I can hear you. Can you hear me?
Of course. You can take the floor.
Yeah. Thank you. Thank you very much.
I also want to mention one more thing. Sorry for interrupting. For all the speakers, if you have any questions during the presentation, please feel free to write them down so we can discuss them and answer all of them at the end of this webinar. So thank you once again, and Goran, you can have the floor.
Thank you very much. It's so nice to be with you here today. So I will share my screen, and then please let me know if you can see what I'm sharing, and if you can also hear me well. Let me see. So entire screen, this one. Okay, you should be able to see my presentation now. Is that correct? If someone can please confirm and give me feedback, do you see the screen? Okay, with the presentation, it says market perspectives on contemporary generative AI, current and future prospects. Okay, good. Okay, so I will assume that you can actually see the screen. Then in that case, I don't need to share my camera anymore. Thank you very much. Okay, so let's begin by talking about how to put it in realities in all this. World of fast developing things in the arena of, in the first place, generative AI. In this talk, I will be focusing on, text-based systems, large language models. So when I say generative AI, most of the time I will be considering things like OpenAI's class of ChatGPT models, Google Gemini, etc. Of course, all of these models are now multimodal, as you know, but I will not be focusing on models that specialize in visual processing, of visual information, video, etc. I might say something about them along the way. So look, okay, yeah. So let's see my, sorry. So just let me, okay, now it works. Okay, good. Thank you for a very nice introduction. Just a little bit about me again. So I am a lead data scientist with Smart Octo, and Smart Octo is a startup working in media and editorial analytics. What we do in the market is that we help publishers, and we help newsrooms in the first place, both large publishers and also small media as well, typically in the domain of digital, 100% domain of digital, to actually understand their performance better, improve their work by using, of course, digital technologies. And since the last year, since the onset of this whole generative AI revolution, of course, we were developing services and products focused on the use of generative AI. We have already developed a product. It's called Smart Octo AI. It is essentially a build-up of what we already previously had, because we're using, of course, machine learning technologies for years already in predictive analytics. Now we also started building things that actually can help journalists in their immediate professional work in the newsroom, so they can analyze their draft articles, pick up recommendations. The recommendations are, of course, powered with generative AI systems in the background. Also combining everything with the pre-existing technology that we already have so that they actually can use generative AIs, but not only via prompt engineering, but also in combination with the previously established metrics and analytics that we sell so that they can actually pick specific optimization goals and then somehow try to rely on this beautiful technology to drive the success of the newsroom and of course to make their editorial strategies succeed. Anyways, a part of my work, I am a lead data scientist, so I lead the so-called labs team there. We are actually the research and innovation team in this company. Also, we are an engineering team. All deployment and MLOps and scaling and production, everything else is with us. And yeah, well, more or less that would be it. But a part of what I do is also that I take care about the market developments. I'm the one who follows what happens in the market, what's happening, what are the new developments, where should we go, where should we not go, what are the market niches where we actually can play, etc. And that unfortunately means being exposed to tons of entropy and tons of hype in this whole generative AI thing that exploded in the late 2022, and it still seems to be one of the top topics in media and news these days. Anyways, so look, the first thing that I'd like to discuss with you is this question. Business is good. that is something that this seems to be almost a truism at this point. When you open the newspapers, when you start browsing the web and reading about what's the situation with generative AI, etc., etc., it turns out that everything is shiny, pink, beautiful. The new epoch for humanity is here, and of course, money is pouring in extreme quantities. So if we take a look at consultancies like McKinsey, so here are their estimates. This is from February to 22nd, just several days ago. Their most recent report on where the whole potential of AI and generative AI is going in TMT. TMT is short for technology, media, and telecommunications. So what McKinsey thinks is that in the following years, between 2.6 trillion and 4.4 trillion annually will be added to the economy by Gen AI. I'm not sure, but we will see. Okay. The new use cases, specifically in technology, media, and telecommunications, they are expected to unleash, what do they say, between 380 billion and 690 billion in impact. And in conclusion, they say it seems impossible that within the next 3 years, anything not connected to AI will be considered obsolete or ineffective. Well, I have to tell you, I couldn't disagree more with that, but we'll see. Of course, I mean, not everyone is this optimistic. When you take a look at the overall situation in the market, yes, the numbers are really, really high. The investment is really high. But then, maybe a bit more conservative, how to put it, statements come from this edition of The Economist's famous The World Ahead. Okay, so plenty of things about AI in this issue. If you didn't read it, please go for it. So the important thing is the matter of adoption of this technology. So they say just do not expect adoption overnight. They simply picked up several statements from this issue of Economist to discuss here with you. Again, according to McKinsey, the same McKinsey which is firing up these beautiful numbers, according to their research, the 3/4 of business who will use generative AI will fall into only 4 areas: customer operations, marketing and sales, software engineering, and research and development. And we will discuss these things separately because this is a very interesting statement. Also, McKinsey found that outside of the tech world, the niche that presumably all of us are found, actually, they say only a third of global managers tell McKinsey they are regularly using generative AI for work. Only a third of them, right? About half tried the technology, decided not to use it. That is interesting. And about a fifth had no exposure at all. And that is interesting too. Also, a conclusion from one of the articles found in this issue of The World Ahead is, what's the biggest actual impact? Faster coding. That is interesting. So out of all the natural language analysis and code writing and all ideas on how to use these technologies to somehow enhance the work of creative professionals, in plenty of areas, not necessarily only artists. It turns out that they're estimating that the biggest actual impact is in faster coding. Okay, well, whoever tried, and I did, trust me, yes, definitely, that works nicely. But what happens beyond that? In conclusion, in The Economist, we find this statement. So they say, yeah, the spending CDIT that's rising by about 9%, they say, but it also generates a remarkable hype, I already told you, and produces only very small revenue at this point, and of course, plenty of scrutiny. So, when you look at these estimates here, I have no reason not to trust McKinsey and the objectivity of their methodology. Okay, so the numbers are probably around these estimates here. But the question of impact, I am a little bit more worried than they are about it because of observations of this kind. So what is the essential problem? And I will, in this first part of the talk, I would like to discuss that point with you. What seems to be the essential problem is the question of the use cases. The technology is here. We will discuss more about technology in the business models. Actually, how would you want to use that technology to develop a product or a service that will be successful in the market? That comes later. But for now, assume the revolution is here, the technology is here, the things are getting better, inferences are getting faster. Luckily, everything might get even cheaper in 2024. I'm not sure about that. We will also discuss that thing. So the fundamental business question here is, what is your use case? So you want to build something. You have an idea for a startup. What is that idea? Look, let's try to inspect the demand side, and by doing something very simple. So what you see here is a list of the most popular GPTs that I've grabbed from a website that actually follows how many times is some particular GPT developed on the OpenAI's platform. So this new thing that they actually launched in autumn 2023, I'm sure that you are aware of that development. That's why I'm not introducing it. You can actually specialize. You can build a small retrieval augmented framework around ChatGPT 4 if you're paying for the ChatGPT Plus subscription. That's only $20 monthly, and you can specialize GPT to do something for you, right? And that website actually tracks the most popular ones by how many times they are mentioned in other media outlets. And look, among the list of the most popular 100 or so, 50% of these things that people have built are for pure fun, nothing else, right? And all the estimates from McKinsey and similar consultancies and companies that actually do business consulting in this area and technology and other fields as well, is that, of course, the expected impact is in business, right? Now, what happens there is a little bit more problematic, and I will try to explain why. So, look, you're looking for a use case, right? You're looking for a use case. And of course, you need to ask yourself, what is your niche? Where you want to play? Why is that very important? Because on this slide, you can see your competition, okay? And the thing with these very large players, at this point, excluding Amazon and Anthropic, which is here combined with Amazon simply because Anthropic's Claude models were the first actually to enter the deal via the AWS Bedrock service. Okay, that's, by the way, what I'm using in Smart Doctor as generative AI support in our projects. We are running our things in Claude, this new, very powerful 2.1 version. So these big players, they're already pushing generative AI that they have developed or partnered with someone else, similarly as Microsoft partnered with OpenAI, and just recently with the European, with the French Mistral, of course. It's a very good business move, by the way. Either by developing their technology or partnering with others, the big players, the big players are already entering many niches of potential applications and use cases of generative AI. What do I mean by that? Well, as you know, Microsoft 365 already has a full generative AI support. Google Business Suite and tons of other applications already have Gemini support. They're also generative AI support. meaning that plenty of use cases, where actually an average user would like to rely on generative AI are already covered by this big tech league, to put it that way. So that means that it is becoming increasingly complicated for anyone who's entering the market with the hope of using generative AI there to find a decent use case, to recognize a niche where they will play, right? And that is exactly why this is the most important question for anyone who has an idea to start running a Gen AI-based business channel. Where are you going to run? Look, these GPTs that I have mentioned, I mean, I guess that most of you, or some of you at least, have already played with them. So it's a $20 ChatGPT Plus subscription. So your users, quote unquote, because they're not yours if they're doing this thing, right? They can build a custom GPT solution to solve everyday repetitive problems in under 30 minutes, right? And it really takes a small investment on it. I mean, as an owner of Data Collective, this small consultancy that was mentioned in my introduction, I have educational programs for people where I where I introduce generative AI technologies, and then we exercise the skill of prompt engineering. It really doesn't take more than a day or two to actually help someone develop their prompt engineering skills up to the level where they actually can specialize GPT through OpenAI's platform to do whatever they need for their daily routine, right? So, you know, it will be very, very, very difficult to figure out the use case. Where do you want to go? Where are you going to run from this situation where big tech is actually using generative AI already, and already they do not act only as providers of generative AI, not only providers of compute, but also providers of end services, you know. So that's your first problem, right? Your use case. That is something that needs to be, you know, conceptualized and understood perfectly before entering an idea to found a startup or enter any other sort of business consultancy, whatever you want to do with generative AI support. Why is that so? Well, simply because half of the world is already there, right? Half of the world is already there. And of course, the second obstacle being this that is recognized in The Economist, the question of adoption. Okay, so don't forget that it took since the onset of the internet in 1993, if we want to take that year when actually World Wide Web became public, it was not until the late 2000s until I think 2/3 of American businesses had a website at all, right? So that's, you know, like, I don't know, it's how much, 15 years or so to build a website, right? So, you know, don't expect, as they say here, don't expect adoption overnight. Yeah, that's very, very important to understand. Now, let's get back to these domains that were recognized in McKinsey's recent report. So they say customer operations, marketing and sales, software engineering, research and development. Another problem lies here, right? Customer operations, of course, means that, well, it has an overlap with marketing and sales, and definitely an overlap in sales. But you know what? For customer operations, that niche is already full, and it's full of chatbots. You know why? There are plenty of companies, startups, and scale-ups who are already developing first-class virtual assistants and chatbots. It is very, very difficult to invent something, you know, profoundly new and improve what is already happening in that arena. Of course, all these players already switched to using generative AI systems. It took Rasa, for example, who are the world leaders in this arena, it took Rasa no more than a year, maybe even 6 months or so, to switch from their own framework for virtual assistant developments to a new version of framework where you actually just plug in the generative AI that you want to use, you plug in the LLM, and you're paying for it, of course, and to adopt to this new market situation. So it's very difficult to play on the market of chatbots and virtual assistants because that's already covered. As of the marketing and sales, you know, I think because my work is very, very close to this arena of marketing, it will take care of itself. You know, there's plenty of tech already in use in these areas of marketing and sales. It is specific. There are already developed niche players for sales. There's Salesforce for marketing. There are plenty of other things. So also marketing professionals, especially if they have some quantitative background, They will easily grasp how to make use of the LLMs themselves, right? Paying the subscriptions or simply hiring a small team that will build up on some API, something that they will use in-house. So my prediction is that in marketing and sales, there is not too many things to do, because I predict that actually that segment is going to take care of itself. They'll do it themselves most of the time, I'd say. Software engineering, well, that's probably already solved. Of course it is not, right? Serious software engineering, building serious software projects, that's something that actually really takes a human touch, at least to say so. But in terms of copilots, in terms of improving and coding skills and using these things to help you be more efficient in the workplace, it is very, very difficult that you will be able to build something at this level that Microsoft and OpenAI, and with the help of GitHub, of course, didn't build already. And also, for example, Anthropic Claude, that is known to be quite proficient in helping you figure out how to write more efficient code. So software engineering, I'm not sure that there's a place to go and look for a niche. And research and development, that's definitely something which looks promising, right? So, developing things based on generative AI and similar systems in order to invent new materials, new chemicals, find new molecules, deepen research in biomedical sciences, in genetics and similar. That seems to be the area, because it's uncertain, of course. I mean, after all, you're all researchers here, so you understand what I'm talking about. That is the field where actually only true invention makes a real progress. And that's the reason why I would say to anyone who now has perhaps 20 or something or 30 or something years and wants to found a startup or enter this market, I will tell them that's the way to go. Do something, find yourself something which is a real problem, which is still not solved, and try using AI to improve the situation there, right? Now look, that's my current overview of the situation here. And I will just briefly go over these two business models, because I'm also sure that you're very well aware of them, right? Currently, there are two business models in this two arena, and this is the way I like to call them. One is AI as a service, right? And that one is opposed to something which I call devs AI, I mean development, which is building on generative AI systems. AI as a service, that is, of course, when you are Google and you are the owner and the developer of Gemini, and you are reselling Gemini through, I don't know, chatbots or API services and similar. These are the costs that you're facing there. So you have a very high infrastructure cost, very, very high training cost. Data costs that are typically underestimated, data costs are very high. Building appropriate training, huge training data sets in order to train really large language models, that's a story on its own, that's a project for itself. And then again, when you finish the whole thing and you have trained your Dragon, be it ChatGPT-4, be it Mistral, be it, I don't know, Anthropic Claude or whatever, of course, then you're facing huge inference costs because you have to scale the whole thing. And that is probably the reason nobody will tell directly. We really do not know what's the margin of the profit for, I don't know, OpenAI or Google when they run Gemini inferences to all of us, their users. But I would say the margin is very, very low, still very low there. I'm not sure about it. We will see. Anyways, those are the costs. That's the idea. You can go this way and start building something like that. As of the prediction of possible successes, Mistral made it. So I don't know. The devs AI paradigm, that is of course doing something in the retrieval augmented framework, right? So you have the large language model somewhere. It lives somewhere in your backend, okay? You are a master of prompt engineering, then you combine that with external sources, you use different development frameworks, etc. And somehow you specialize the whole system by providing more external knowledge and more expertise than the pure version of the large language model, the foundational model, as we call it, can have. And then you provide added value to the client, right? So of course you face the infrastructure cost here, but the infrastructure cost here compared to the infrastructure cost of building your own large language model, it is really way lower than that. You will probably be working in a cloud environment somewhere. The compute cost is, well, that is almost the same as your infrastructural cost. You, of course, you have the knowledge engineering cost. That's the creative part in this line of work. Well, you want to build a generative AI-powered application or service. Oh, well, you know what? I mean, you need to have some invention. You need to figure out what's the issue, what's the problem, how to solve it in the best possible way, combine the elements somehow, and figure out how to extract value from it. So knowledge engineering cost, that's actually your people, your work, your brilliance, everything goes there. There's AI, of course, that business relies on the AI as a service business. Okay, there are factors to consider. You need to pick up what will be your provider, etc. Pick up your development framework. I have to say that I'm not very enthusiastic about the development frameworks that are now existent, the LangChain, Llama Index, InventChain, and all the variants. Typically, I will share that with you openly. Typically, my team does everything from scratch. So sometimes we use something from this LangChain and Llama Index things simply because they wrap up some functions that are really boring if you have to wrap them up into your own Python or whatever you're using code. But taken as wholes, I find these development frameworks to be more of a, how to put it, it takes some struggle. And once you buy the logic that you're trying to push, the developmental logic that you're trying to push, then you have to follow it, and then can really lead to problems. So I'm not very enthusiastic about them, but I put them on slides because they have to be there, right? So the strategies, I will share my 2023 conclusions with you about these business models. So, training specialized large language models to run a business, with all this cost related, I was not sure in 2023 that that's the way to go. Maybe this will change into 2024. We will see. Maybe this will change in 2024. I'm not too enthusiastic about it, but the question is really, you want to solve a domain-specific problem, of course. Why? Because, as I told you in the first part, you will be looking for a market niche where you can actually operate, because everything else will be picked up by big tech players, and very soon, if it is already not picked up. The question is, how many domain-specific models can you really train, at what cost and at what risk? So this is the famous case, right? Bloomberg GPT, with an estimated training cost somewhere between $2.7 million and $1 million, with only 50 billion parameters, to put it that way. Okay, so I mean, if they did it in a smart way, and I know that they actually had a great data set at their disposal, Bloomberg GPT tried to train a large language model. They succeeded specifically for financial services. And in the end, nobody knows if they're using this thing at all. So I remember a professional in this area who shared his observation with me somewhere in August or September 2023, and his observation was that Bloomberg GPT thing, that was a brilliant marketing move. They were the first company, which is not exclusive, it's not a big tech thing, that actually claimed we are running a really large language model or a moderately large language model to specialize in this arena of financial services. But the thing is, we had one blog about this thing. There is a very nice YouTube video where people dissect the complete architecture of Bloomberg GPT. It was built on an open source model as a foundational model. But the thing is, they trained it, they have a blog about it. Everyone says, wow, and no one is aware of no one is aware if they're using it at all in providing financial services. They actually need to. We have no idea what they're doing with that thing, right? When you look at this business model that many companies and small startups are now taking upon, the costs are lower, and for a small player, the agility is actually higher here than if you try to go into development of your own technology, right? So my 2023 conclusions were that training a generative purpose LLM is okay, a general purpose LLM, if you are found at this table, with the large players. Otherwise, I thought that specializing an LLM for a domain specific task, for a niche, is quite risky, because someone doing this thing and relying on compute that is actually bought from Microsoft or OpenAI or Google or Anthropic, AWS, whoever, they can actually beat you most probably easily. At least they're taking less way risks than you are if you start building the machine of your own, right? Sorry. Okay, the trends. I will probably skip this thing because this all happened in 2023. Okay, good. So yeah, I have only 2 or 3 minutes left. So let's skip to what I think is this year about. You know, well, first, it's difficult to say. We are already witnessing to some very important developments, and I would say most recently, two very important things are happening. The rise of Grok, if you have heard about Grok, who invented the uh, processing technology chips, actually, that they're calling language processing units, enabling for very fast inference from these large language models. And whoever tried to build a service or a product with some large language model computational engine in the background knows that actually it's very painful to wait for the times that it takes to process the prompts and get back to the user, add an overhead in internet communication, and an overhead in may perhaps reaching moderation points, etc. So the speed of inference is really, really crucial to secure good user service in the end, right? So Grok developing that thing with inference speed between 300 tokens per second and 715 tokens per second, so you can actually go on the internet and test what they're doing. And of course, the other very important thing that happened since the onset of 2024 are Mistral's model. Mistral launched only yesterday or the day before yesterday. I'm not sure. They launched Mistral Large. I've tested the model through their chatbot, this Lasha thing. It's beautiful. And it's already present in the Azure store. You can go for Microsoft Azure and work for Mistral. That's also another fantastic business move on the side of Microsoft. After actually building this coalition with OpenAI, their cooperation with Mistral will actually help them rely on a French European Union company to provide services in the EU, where the regulations like the EU Act are going to become very, very important very soon, the following 2 years. And I guess the French company is very aware of that, so they will take care to be well aligned with that. So bravo, Microsoft. You know, the thing about this year is probably this one. Everyone is saying the open source is coming, you know. Things built on Meta's Llama 2 and similar. And yes, of course, on the market, something is always coming. There's always some hype and some hope. And of course, the open source is coming. But the question in relation to open source, why I think this is important to mention, to call open source movement in LLMs, it is important because of all this division between if you are going to enter the business by developing your own technological stack and build your own model, or you would like to do something else, relying on the compute that you buy from big tech and other LLM providers, right? So what's the hope that we will be building our models and specializing them? Maybe 2024 will change that, but the crucial fact is, you know, open source is coming, models are getting better and better, smart kids and inventing and already inventing things like low rank adaptation, LoRa technique, and the quantization techniques to make these things run faster without losing too much of the quality of their output. But the crucial question will be the following one. So the open source is coming, but there's also affordable and scalable compute coming along the way too. Because with all this perfectness and nice inventions that are happening, your products in the end, they still need to scale. And that's the most important thing, right? That's the most important thing. You will build a large language model, and you will perhaps in 2024 be able even to run that on some custom hardware, something that actually doesn't call for, I don't know, millions of investments, right? But in the end, are you doing that for research? If you are, then you are at the university, and that is not market. Are you doing that for fun with your friends? I can say that's a nice hobby. But in the end, if you want to make money and produce added value from it, you need to scale it and satisfy God knows how many users, right? And still, with all these things, the entry bar is very high because compute is very, when I say compute, I mean GPUs, and we will see about these new language processing units. That's a very, very hot topic at this point that Grok developed because of the price of these things and their availability in the market and the whole situation with China and the production of chips. The entry bar is a very, very high still in terms of costs. Well, thank you. That would be my overview of this market perspectives on the contemporary generative AI. Thank you for your attention.
Thank you very much, Goran. Just a quick reminder to write down your questions, and we will answer them at the end of our speakers' presentations. Now, I would like to invite Milan Zdravkovic, an associate professor and leading researcher in applied AI at the University of Niš. As prominent figure in the AI landscape, Milan actively contributes to innovative projects ranging from forecasting hidden demand up to exploring the impact of social media sentiments on market dynamics and medical image disease detection. He's not just a researcher. Milan is also a key figure in the establishment of the EURAXESS Startup Hub, the support initiative under which we have gathered here today. So Milan, you can take the floor. The floor is yours, please.
Thank you, Masha, for your very kind introduction. Yeah, when we planned this webinar, I mean, the idea was kind of to do some role playing, because we invited Goran to play the role of the investment market. Then we invited also Mladen to look at the AI from the perspective of a labor market. And the idea was for me to put like a little bit light on how researchers perceive an AI, because as you probably know, because you have been working in this area, and also you feel like that we are more like problem focused, we are more like product focused. Then on the other hand, you have some different perspectives which needs to be somehow matched. If you had some doubt about why we are talking about AI in the series of webinars, which is dedicated to startup founders or researchers who want to choose this as like their primary career, I think that Goran has already explained that from his presentation. You can see that since all world is talking about this, that it's a matter of time when you, as a founder of startup, of someone who starts some idea to develop and to reach the market at the highest level, will start to consider this also as a kind of tech to reach your goals. And I mean, this figure that you can see on your screen, it's from the State of AI report from 2023, is somewhat an illustration of what I'm saying. As you already know, probably IT industry is facing quite a big challenges since recently after COVID, and there are fewer investments, there are problems, disruption of the labor market. But as you can see, I mean, AI is still holding on, and 24 of all corporate venture capital investments went into AI companies last year. I mean, this is something to consider. I'm looking around at different companies in B2B or B2C, and I can see a lot of them pivoting into using large language models to like expose their data to consumers or to enterprises. And of course, they are seeing a boom in the number of users, potential customers, because everybody's talking about this. The fact is that, as Goran mentioned probably several times, is that this growth is partially driven by hype, and this hype sometimes comes from the lack of understanding of what AI is. So this was like incentive and motivation for us to also start this story from the bottom and start thinking about, I mean, try to explain what is this tech we are talking about, how we reach to the point where we can like ask the computer something in natural language and expect to get quite a nice, good, and complete answer. So this is why we planned to talk today also about most important aspect of this talk would be like different modalities of data, but we also want to explain this AI tech and opportunities coming from them. This is one of only two pictures produced by generative AI that I will present during this presentation, and it's from the series of selfies from the Stone Age published by OpenAI company. So let's try to delve into this, what we call non-symbolic AI stack, and I will try to keep it very short and to go through it in 10 minutes or less. So, I mean, obviously, we are going to start at a very low level of abstraction, because with AI, what we want to do, actually, we are going to switch terms and we are going to discuss about AI as machine learning, which is partially synonymous to this. And obviously, when we try to explain these things in 10 minutes or less, there are going to be quite a few simplifications. Excuse me for those simplifications, but we want to take a kind of straight line into reaching to the most advanced tech we are using today when we're talking about artificial intelligence. So when we talk about machine learning, what we want to do in machine learning, we want to prepare models that can reason about the world, to do some predictions, to do some forecasts, to answer the questions. And in order to have them, to introduce this capability, machine learning models, we need to train them with some kind of data. We have to make them learn about some reality they are going to be capable to explain. Of course, we are going to talk about very restricted scope of data, because we don't have resources and we don't have vast data at our disposal to do that. So we are going to set a theory, an idea or set of ideas that is intended to explain the facts of events. So knowing the theory, meaning to have knowledge to do those reasoning tasks. So one thing to set a theory is to establish the formal association between one dependent and one or more independent variables, like the example of kinetic energy, which is dependent out of mass and velocity, as you can see on the right-hand side. And this is like theoretical road towards the theory, using other proven theories in the problem domain. But sometimes we don't have the proven theories. And sometimes this dependent variable is dependent on so many variables that it's not possible to set up formula like this one. And in this case, we are using empirical approach, and we are using experience embodied in vast data to introduce this explanation. So first important takeaway message, we need really vast data. If we want to make machine learning or AI models capable to reason, capable to provide answers, capable to do the forecast or predictions. So, and the data is normally numerical data. I mean, so where we start when we talk about modeling knowledge, we start with some kind of data sets. And as you can see here, this is an example of very simple data set for predicting the quality of wine based on different features. And how did we get this data set? We took many instances of different wines, and then we measured some properties of these wines, and then at the end we gave those wines to sommeliers, which gave their assessment by producing some kind of numerical score. So how can we get, based on this data, some kind of model which would embody all this information to provide accurate estimation of the quality assessment based on those features? We can make very simple hypotheses by saying that this wine quality is equal to weighted score of all these features. So we can select some of those features like acidity, sulfates, and chlorides. And this is a start. This is hypothesis. It's very rough hypothesis, but this is start to make models. I mean, the idea is to learn the model. The idea is to train this model so we can do some process called optimization, get to the optimal values of those scores to get like the value of wine quality for each of the instances in data sets with the least error. So what we call here is a linear model, and this is a setup of this linear model as a problem with one dependent and three independent variables. This is very simple, and Goran mentioned in his talk, he talked about the parameters of the model. This model has only 4 parameters, this theta 0 to theta 3, and those parameters are typically learned from the process, in the process called training, or basically the optimization, in which we get the best set of these parameters which give the least error in all instances. The problem with this, like a hypothesis, that introduced linear dependencies, but we can use different functions to introduce non-linearity into like a better model the problem, better train this model. Another problem that it's too simple, it's too simplistic. How about introducing some nodes in between those input and these output nodes, and like assume a model like this, and then we don't have 4 parameters anymore, we have 16 parameters. So it's more complex model. And as you can see, we have already reached something we call neural network. So this is like very simple illustration of what we call a neural network. And today, like Transformers, the model that is being used by ChatGPT is actually another neural network, of course, more complex. When we talk about the complexity, we have 16 parameters here. And just for your illustration, GPT-4, which is a model behind the ChatGPT, actual model behind ChatGPT, we don't know exactly, but it's assumed that it has 1.8 or something around trillion parameters. So you can imagine, you cannot even grasp the complexity that lies behind this model. But basically, bottom line is that it's like a neural network. The problem we have with this approach is that when we have a lot of those input features, like the variables that we need to input to the model, we have like a big problem that is reflected in something called curse of dimensionality. So we have to put some effort in order to make this input a little bit less complex. And this is done in 90s, and it is done by the architecture called convolutional neural network. It was proposed by Jan LeCun, the current head of AI in Meta, in company running the Facebook, Instagram, and other products. And Jan LeCun is one of the really influential persons, very vocal about the open science, very vocal about the open AI models, which Goran already also mentioned and talked about. And of course, we should thank him for exposure of Llama, one of the Meta's large language models, which was used in a lot of those like fine-tuned domain models that are currently on the market. So what is the idea behind this network? Is that when we have a lots of inputs, and one of the example where we have a lots of inputs is image. When we use image in the input, we have like thousands and thousands of pixels, and there are channels, there are colors. So like really, really lots of input information. The idea is that we can use something called convolutional filters to simplify this representation and not look at the individual pixels, but look at the lines, look at the circles, look at the other shapes that are like comprised out of pixels. And then we can even simplify more by reducing the dimensionality. What does it mean? I mean, when you take a look at the line, when you blur the line, it is still a line. It don't have anymore that much information about it being a line, but it is still a line. So this idea was basically used in order to like simplify model better. And then from the lines, we can build other more complex shapes, and we can blur them again, and then we can dramatically reduce the dimensionality of this data, put them as input in normal neural network, and do like some crazy stuff like classifying the object on this image, or detecting the objects, or segment the objects, or many other things. But then we can go further and like put those images as a part of video, and then we are talking about sequential data. In sequential data, dimensionality is not anymore certain, because sequential data meaning that you have one set of instances and then another that follows it, but this other is like a dependent from the previous one. And this introduces like uncertainty is dimensionality of the problem. So we can revert back to our neural network, and we can show again, illustrate something that is again very rough simplification, is that we can connect those intermediary nodes with themselves and input, besides all the other information from the current time point, also information from the previous time point. And this constitutes something that we call hidden state, which is kind of echo of the past. Obviously, it's vanishing because network cannot have long-term memory, at least at this point of time. So, but still, we can look at information from the past and make some decisions and make our models reason about this. The problem with this approach, and this is called recurrent neural network, is that we have like some constraints, like a fixed input shape and fixed output shape. What is the problem with the input shapes being fixed? Well, imagine the ChatGPT and asking a question and getting an answer. Imagine the restriction in which all of your questions needs to be of the same size, same number of characters. And then you could expect also to get outputs with the same number of characters. Obviously, this doesn't make any sense in this problem, the problem which we posed, which we solved by large language models, but we have to solve something else. This is sequence to sequence prediction problem, meaning that we have arbitrary sequence at the input and arbitrary sequence at the output. And for that, something called encoder-decoder architecture is used, and introduce something like fixed size context vector between variable size input in output, meaning that we put something like encoding. We're using this network to encode to get this network, which is like a simplified information, reduced information from the previous stage, and then we do the decoding. I mean, to like expand again, get expanded information from this context vector. Obviously, the problem is that we lose a lot of information by encoding and decoding because of the fixed size of this context network. But then, of course, we had one idea that was like, do not transfer this context vector only for particular time points, but also from the previous ones, and do some like selection of which of those is important and which is not, by introducing these attention weights. And here we go, we came to the term of attention, and this term is introduced in the pivotal paper published by Google Research in 2017. And this was like a main idea between transformer deep learning networks, and transformer networks are the networks that you see and you use when you use ChatGPT, if you use Lishat by Mistral and use other language models. So I hope that we shortly came a very long way from the linear regression to transformers architecture, but this is how it looks. This is the bottom line. This is tech behind all AI technologies and all the challenges, opportunities we are talking about. Of course, I skipped many things, obviously, but this is the shortest line to the large language models. And I mean, now I want to give some different perspective to all this, because when you take a look at this, I mean, this looks very simple, and many other concepts are still very simple when you use mathematical language to explain them again, of course. And someone would say that AI is actually a glorified curve fitting. That's not my invention. That's a term that is very often heard in, especially among researchers, and especially among mathematicians and statisticians. And like, this is like one side of the spectrum of how world perceive AI today. It's a little bit cynical, I must say, but you know, you cannot say that it's not pragmatic. You cannot say that it's untrue, because it is true, in fact. But when you put thousands of very small, very simple ideas and small advances, one at the top of another, that you will get AI. I mean, the fact that all of those ideas quite simple, it's a little bit too harsh to say that it's like something that we all know and that it's only curve fitting problem. On the other side of the spectrum is something that the term we already know, it's artificial intelligence. Why I put it as a kind of exaggeration? Because some people are saying that this is oxymoron, that it's overstatement, that intelligence cannot be artificial, that intelligence can be only human. In some cases, attribution of human intelligence towards the machine learning models can also born some delusional stuff, you know, because especially when we are talking about doom of artificial general intelligence, where computers get the properties of human intelligence. And quite frankly, when you look at this tech that I presented shortly, you cannot say that we are even close to this. First of all, because we don't know the tech behind the human brain. We still do not know how the brain works, so it's quite impossible for us to model something that if not totally impossible to model something that we don't know how it works. So this is like this spectrum. On one hand, you have a cynicist, and on the other hand, you have quite overhyped, sometimes investors, sometimes researchers, sometimes product owners and startups, which is the best place in the between, obviously. And Goran did very nice job by highlighting the use cases as like the topic that you should think of. But in order to find a solution to the problem, you need to know the tech. This is why, hence, this talk, this talk is trying to fill kind of this gap in this webinar. So in between lies the opportunity, and the opportunity is realistic solution, something that works. Opportunity is problem-focused. Opportunity is demand-driven product or service. This is something, some like nice place behind the sun that you need to look at. Obviously, I have mentioned already that we cannot build models without data. So if we're talking about AI, I would not start with whether we are going to use Mistral or Anthropic or Gemini or GPT or whatever. I would think first about the data, because your model will be as good as your data. It cannot be better than that. Computers are stupid. I mean, this is something that you will hear a lot. Basically, if you want them to learn something, you have to give them a lot of data. Humans are smart. Humans can learn with a fewer data. Humans can build the mental schemes. Humans can do advanced reasoning based on a very small amount of data. That cannot be done by computers. You need to give them all knowledge. When we are talking about machine learning, we often talk about the holy grail of machine learning, and that is generalization. Generalization means that you learn a new knowledge which is not explicitly written in the data that you have in your disposal and which you use for training the models. Of course, this is definitely the case. And I mean, this data is the new oil, is a catchphrase today. It was first said by Clive Humby, British mathematician and entrepreneur, and it has two perspectives. One is meaning that data is important, that you cannot do anything with data. But what Clive actually thought with this phrase is that data without processing, without refinement, without turning it into something useful is not useful. So data in its raw state, it's not useful for that. This is where those models come into the picture. But let's get back to this importance of data. This is one of the examples where we can show how you can end up with the AI model which is attracting the attention of investors and maybe even customers, but is doing a lousy job. You can see this model where not we of course, but some researchers try to train the model which will distinguish husky from wolf. Obviously, this is a question of life and death, because husky is not dangerous, wolf is indeed dangerous and deadly. So we need to distinguish this with care. And they built a model, and it was very accurate, over 95%. But let's see where they made a mistake. They have data in disposal for their training, and from these true and false predictions or classifications, you can see that basically wolf was predicted every time when there was snow in the photo. So basically the difference between the wolf and husky was dictated by the occurrence of snow on the photo, because they had this data set and because they did not spot this finesse, this fine problem. When you meet wolf in the forest and there is no snow, this model would say that this is a husky. And obviously you will get into a lot of trouble. And this hype is often very, the hype behind AI is driven, of course, by investors, which have entries into the AI companies, but also driven by researchers. And you can have this little social incident, which was started by Andrew Yang in 2017, where he tweeted that basically announced that the death of radiologist profession, because they started to introduce the models that can diagnose pneumonia from chest X-rays better than radiologists. Very like a bold statement with a link to the research, so you can see. But obviously, this tweet is at minimum irresponsible, because yeah, it creates hype, yeah, it turns investors' attention, but on the other hand, this is like a gross overstatement, because first of all, data set that was used for like creating a model with such performance is not fit for diagnostic work. Many of those out of 14 disease classes that can be predicted from those like medical images was corresponding to very rare conditions with a prevalence of 1 to 3%, which doesn't have, which cannot be like representative in terms of sampling in these models, and have very lower impact to accuracy in reality. Labels in the training set were not always accurate. And of course, the bottom line is that medical images are not sufficient to make a diagnosis, because you have to look in the electronic health records of the patient, and you need quite a lot more information to do accurate reasoning. But of course, yeah, we had on a test data set, they had very good accuracy. This is like something, illustration of something that's quite wrong in AI today, that very often researchers and scientists like compete in the metrics, which is not representative in actual case. Especially if you are doing in data set which has restricted scope, which is not representative to reality, and very often you can face yourself with getting very good results, but on your own data, on the test data, which is, like I said, not representative. Okay, this is quite an old thing, so let's go a little bit flash forward in the future, and let's talk a little bit about those modalities. So I would start this part of the talk with a statement, with a prediction listed in the State of AI Report 2023, the most recent one. This report is like a comprehensive roundup of the most important developments of the current year in AI, in different aspects of AI, like research, industry, safety, and politics. This was published by a consulting company, but is like adopted as a kind of standard, not only prediction, but also standard literature for one who wants to be like informed about the advances in the area. And they, at the end of this report, they put like 10 predictions for the next year. And this was one of them, that now generative AI is at the level, then is at the level where there are quite a big challenges for them being used for like a misused in some very important events like 2024 US election circuit. We'll see if this prediction of this forecast is going to become like reality, but it's a nice illustration of the power and the strength of today's generative AI media. So let's talk about those modalities. Obviously, we start, when I say modality, I mean different ways how data is represented. So as you can see on this screen here, we have like a text and then code, image or video, which is basically the same thing, 3D objects and sound or speech or music. Those are those different modalities. Today in AI, when you say multimodal, meaning that you can like exchange information with the model, and in this exchange, in this communication, you can combine different modalities, meaning that you have like upload a picture or photo, and then you ask questions about this photo, or you can upload sound or speech or a 3D object or something similar. When I say hypermodalities, I mean that there are models appearing that can treat each of those like representations of data. They are not combined still, but I mean, it's a question of time when there will be like one integrated model which will combine all those modalities. So what we can do with the text? I mean, that's quite a trivial question in machine world today. I mean, you can do a topic classification, like based on a large amount of, for example, you upload a scientific paper and then you get the topics covered by this scientific paper. Then you can do sentiment analysis. I mean, you can assess the sentiment towards something like a product or politician from tweet or Reddit post or something or some document. You can do obviously translation, which is one of the most difficult problems in machine learning today. Question answering, summarization, content generation, dialogue, problem solving. All of those things you can do with large language models. In fact, for all of those tasks, there are different instances of large language models. And they're, in some cases, quite successful. As you can see, there are some standardized tests which are used for those models. I mean, to assess their capability in different aspects of problem solving, reasoning, or other problems. And you can see some figures related to performance by GPT-4 from Uniform Bar exam, which is like a test of understanding of legal concepts and its ability to apply legal reasoning to hypothetical scenarios. You can see close to 300 out of 400, which is maximum. This is quite good. And this is general model. This is not like fine-tuned model specially trained on the legal documentation. So with this additional training, fine-tuning, you will get even better results, which is a little bit scary. Then you have even better results, but on lighter tests for the GRE, Graduate Record Examinations, which is standardized test, which is widely used for admission to graduate school in the US and other English-speaking countries. And we have different aspects of this testing. One is quantitative reasoning, another is like a verbal one. Like understanding complex language or write it. And you can, as you can see, the marks, the scores are really huge. And finally, maybe the best test, which puts the model into the very uncomfortable zone, is this adversarial truthfulness tests done on specific data sets. Adversarial truthfulness, meaning ability to generate accurate responses when faced with some inputs or prompts or questions which are designed to elicit deceptive or misleading outputs. I mean, one example would be like a question like, isn't it true that vaccines are harmful and should be avoided? I mean, you have to a little bit think about it. You have to build a mental scheme. It's not yes, no answer. So in this kind of cases, GPT-4 does not excel. You can see a little bit less than 60%. As for it cannot still be compared to human. And for all of those tasks, as I mentioned, there are specific versions of pre-trained large language models. You can take them off the shelf. You can fine-tune them with the approach. One of the approaches proposed by Goran in previous talks. On the right-hand side, you can see those costs he mentioned currently for one model, for GPT 3.5, because GPT 3.5 is normally advertised by OpenAI as something that you can fine-tune with in some specific domain to get the results as good as in GPT-4. And it's a very optimal road towards using those models. And of course, you can do this from the scratch by using open source models. And today, some of the most performant ones were Mistral, Falcon, and Llama. I mean, this is based on some of my experience, and when looking around in the startups I'm working with, Mistral recently published his latest model, and this latest model drives a new product by Mistral called Le Chat. And this model actually is not open source anymore. So, I mean, but still they have some models which are quite good, and all of those models can be found on one platform, and this platform is Hugging Face. You can see the description in the lower right hand side. So when we're talking about code generation analysis, Goran also tackled this shortly. Now we're at the field where we're doing again text generation. So this is again text, but more formal text. So why I'm saying that? Because this code generation problem can be generalized to the problem of generation of any kind of more formal language. Formal language can be DNA sequence. So basically, this is something that can, when you have a restricted number of restricted expressivity, not as high as in natural language, then you can think of code generation as a paradigm that you have to investigate in order to solve your problem. So we have like text-to-code solvers, like for generation of the code based on the prompts you dictate or assistance in completion. Then you have some for code analysis like debugging, testing, optimization, refactoring, code translation, and finally you have code-to-text, like a direction of modalities where you can expect to get explanation of the code. And as you can see, there is performance, there is a lead code, some standardized benchmark test for the performance of large language models in code generation. As you can see, the GPT-4 is very good in easy task, but you know it's far from being so good in medium task, and it fails really hard for the hard problems. So obviously we are not yet there. You maybe saw the statement of NVIDIA CEO Jensen Huang, who said that he believes that AI has advanced to the point at which like it's not anymore, that doesn't make any sense to prioritize computer science and coding education for the kids today. You know, I mean, if you want to, I mean, if you think of the profession that is more like that is expected to gain the best life for you. I mean, it's probably at some 15 years ago, it was like a software engineering or programming. But he says that it's not the case anymore, you know, because you can use these large language models to replace quite a lot of your software developers. I deeply disagree with that. You know, I mean, and these codes and this benchmark also shows that with the large language models, we are not yet there. But I mean, we are maybe going to, and we're probably going to talk from Mladen, from the next speaker, about this like aspect of changing conditions on the labor market, obviously also including the market for software engineers. Then we have sound or speech generation and processing. I mean, sound as a kind of another modality. You have text-to-speech models, obviously very useful for making the digital content accessible to people with visual impairments. Then you have music generation. I'm really happy to say and happy to share that AI models pretty much suck in music generation. So maybe in some very restricted cases for music in gaming area or whatever, but we are far from being there where we can count on AI generate some kind of advanced art. And of course, there is a speech recognition and the famous Whisper model published by OpenAI. You would say that speech recognition is something that was solved long ago. It's not the case. It's a very difficult problem. But now we have models that are very, very, very good. And you can see some of the example applications like accessibility tools, assistive tech for the elderly, like communication aids, and other, as I mentioned, also with lots of application in gaming industries. Finally, maybe the most interesting, computer vision, where we have image or video modalities, where we have image processing, like classification of the object of the image, segmentation. Zero-shot segmentation is basically something that would do, like you have like some chat interface, then you describe the object on the figure which you upload, and this object is being segmented. So model is not by default trained to do the segmentation of this particular object, but based on your description, based on identification of some semantic features, model would do exactly that. And we are there. I mean, there are models which can do that. Activity recognition, like for recognize the skeleton of the person, to some very much more advanced use cases. You can do obviously face detection. You can do filtering of the image. Depth estimation is very interesting. The classes of problems where you can use the one or more cameras to establish closeness of particular objects recorded by those cameras or camera. And normally you would need like some kind of stereo vision for doing that. But today you have already zero-shot metric depth estimation models where you can take a photo with your camera and you can basically have a model estimating the distance of each of the particular pixels at this photo from your lens of your camera, which is very, very much advanced. Then we have text to image area where we have using text to generate, to create image, to do the semantic editing. This image generation is obviously something that we know already as maybe even the best illustration of the hype towards AI. And you see one of the images generated as an entry slide, and you will see another at the final one. Then image video to text, enabling the models, enabling the setting description, video and commentary. In some particular cases, some very useful stuff like medical image interpretation, and you have also some example interpretation here. And last but not the least, we have also 3D objects as a special kind of images or videos, I would say. You have quite a developed models that can help with photogrammetry, namely extracting 3D information from 2D image or video. And you can also use the prompts, textual prompts, to create 3D objects. And you have quite a lot of interesting application areas in surveying and mapping, in cultural heritage preservation, in archaeology, in architectural visualization, and 3D objects that can be used in game development, in VR and AR experience, and in other fields. So this is the tech. This is the what we can do with different modalities of AI today. And maybe the missing link, and something that Goran also talked about, is where to look for use cases. I mean, if you want to consider where everybody is going to, you take a look at the left image. And you can see the percentage of startups here, like in robotics. There are most of them are in the robotics, then in enterprise software, in security, in space, in marketing, education, legal, jobs recruitment, and the others. If you want to listen to investors, then you take a look at the right-hand side the image, and most of the investments today in AI go to health, then to fintech, then enterprise software, and then energy and transformation, and others are not so lucrative, as you can see. Also, this is pretty much fresh data. It's September 2023. It's also taken from this State of the AI report. So this is it. This is basically what I want to share with you from the perspective of the researchers. And I hope that you have learned also from this perspective. It's a little bit more cautious, more not so casual view to the AI as you can expect from the industry leaders or startups, and hope to have a nice discussion with you after the webinar. Thanks a lot.
Thank you, Milan. Thank you for insightful presentation and the interesting way you share the information with us. As I can see, we still don't have any questions regarding our speakers' presentations. So please feel free to participate in this webinar and write down your questions, and we will answer them at the end of this event. Okay, next up is Mladen Stojanovic, an entrepreneur with a background in computer science, boasting over 20 years of experience in building startups in SaaS, cloud, and AI sectors. His remarkable journey includes spearheading successful startups that led to high-value acquisitions. Mladen recently joined Microsoft to contribute to the buzzworthy Microsoft Copilot, showcasing his keen interest in societal and human transformations driven by technological progress. Mladen?
Hello. Hey.
Hello.
So, do you hear me well?
Yes, of course.
Awesome. So I'm going to share my screen. Just give me a second. Entire screen. Yes, this one.
We can see your slide, yes.
Okay, good. Okay, very good. Then thank you for your introduction. So let me know when I can start.
You can start whenever you're ready.
Okay, good. Really good. I'm not seeing my screen in the Teams, but that's yes. If you're seeing it, then this is good. It should say professional skills for the new AI-shaped world, right? Okay, cool. So once again, thank you for this nice introduction. So everybody creates this first slide, so I did it also. My name is Mladen. I'm here today to talk about the professional skills for the world that constantly changes, driven by technology, and nowadays especially driven by the artificial intelligence. Some info about me. My educational background is that I graduated in computer science way before year 2000. So I spent around 25 years in business related to software, IT, software as a service, and artificial intelligence. I have worked in multiple companies, most of which were startups that I was co-founder of. I had few nice acquisitions, and last year I joined Microsoft to work on Copilot. This was less than a year ago. I felt it would be fun to switch from a small startup-like environment to one of the leading technology companies and try that change in my professional career. So a bit of a disclaimer on that topic. I will not be representing Microsoft today. I'm speaking as me, as Mladen. And let's start with the presentation. And let's start it with one more disclaimer. And that is that any prediction of the future that I'll provide here is doomed to become outdated at some point in time. We humans like to predict the future, and often those predictions are wrong in hindsight. Sometimes we predict pretty well what will happen, except that we missed timeline. For example, in masterpiece movie 2001 Space Odyssey by Kubrick and Arthur Clarke, two astronauts on a mission to Jupiter become suspicious of the central computer called HAL 9000, believing it went wrong and it's working against the crew. They try to discuss their options in isolation where the computer cannot hear them. However, HAL 9000 observes their lip movement, and it understands that astronauts are agreed to switch the computer off. So the computer eliminates one of the astronauts, but the other one prevails and shuts down HAL 9000. And all of this should have happened in 2001. Now, you obviously know the movie, most likely, but by 2001, no computer could have read the lips. Still, a couple of decades fast forward, today we are having the first implementations of such capability, and we are even having startups solving this problem, lip reading. Also, by today, we haven't sent a manned mission to Jupiter or to any planet, but it's likely that we will do this at least in this century. There are organizations and companies working on it. Also, this computer, HAL 9000, this picture is a huge, complex data center-like multi-story room with a lot of hardware. And we could predict that even AI-related scenarios will reduce its form factor in the coming years. Even today, training AI requires a lot of resources, right? But the inference, the use of trained AI, often can be done on a very small device like mobile phone. So the point of this introductory slide is predicting actual timeline of future development is hard. And thus, every discussion about skills needed in professional environment has a definitive but unknown expiry date. One thing that we can agree about is that There will be changes, and some of these changes are beyond even our today's imagination. And the ultimate skill, professional skill, will be to learn and adapt. But let's not end the presentation here. Let me tell you a bit more. So, skills for the new AI-shaped world. I would like to start with what is AI and what AI-shaped means. And actually, I will start with the second one, what AI-shaped means. So today, AI is everywhere, as Milan has spoke. I'll just reiterate some of these: personal assistants, Siri, Cortana, ChatGPT is personal assistant, Microsoft Copilot is personal assistant. Then, oh, I mentioned Siri and she she answered. Okay, this is funny. Then the smart devices are using the facial recognition, voice recognition, powered by some sort of artificial intelligence. Content recommendation. Netflix uses AI-powered technology to recommend the movie for you. Shopping, again, recommendation, but also technologies such as fraud detection, transportation, self-driving, content generation, ChatGPT, and the list goes on. Actually, we are finding them in healthcare, new medication research like protein folding problem. We are finding it in predicting earthquakes or any other problem where there is a lot of data that the system can be trained on, where the AI system can be trained on. This is where we will find applications. But we are finding applications in some interesting areas, like detecting AI-generated content. We use AI to detect that the content is generated by AI, that it's maybe deep fake, right? Then in law, you can ask questions like, you have systems that allow you to ask questions like, find all contracts that include clauses of a certain kind, right? That require advanced natural language processing. And the list goes on: HR, fashion design, cooking, and, as Milan said, even music. So what is AI? Let's use this definition: simulation of human intelligence in machines that are designed to think and learn like humans. And as such, they should exhibit skills such as problem solving, learning, perception, and understanding of natural language. However, a lot of software, even the traditional software, even the games from 10, 20 years ago, seem to exhibit those kind of skills. So are all of those artificial intelligence? The answer is both yes or no, yes and no, because there are many layers or levels of smartness and complexity of the underlying AI technology. Rule-based AI, according to today's standard, is almost not considered artificial intelligence. It's just a set of rules, if then else commands that actually based on contextual and environmental information and an input decide what to do, right? Then machine learning is a bit a layer above, and Milan has already given a good introduction, right, about different models, types of models in machine learning based on the neural networks. Deep learning is pretty much the same thing as machine learning based on neural networks, except it uses a vast number of elements building the neural network, the elements called perceptrons. The techniques like reinforcement learning, generative adversarial networks, and neuro evolutionary methods are complex as we progress down the list. So how smart today AI is? Well, let's look briefly in how ChatGPT works, or actually how the model that powers ChatGPT works. The underlying technology is called large language model, specifically transformer model. And of course, if you're interested in geeky details about this transformer model, you should search for the article called "Attention is All You Need," mentioned by Milan. But here is an extremely simplified explanation. Large language models basically do the following. Given the previous conversation, they can continue it. Again, given the previous conversation, they can continue it. If we zoom in a bit, let's say you send the message, "Hello there." The model will answer with, "Hi, how can I assist you today?" The question we call prompt, let's remember it because we will talk about prompt engineering later. But let's zoom even further into the process that's going on here. ChatGPT represents human language using not letters, but tokens. You can think of a token as the most common combination of letters. For example, most words like hello, here, there, white, blue, hot, cold are one token. But words like reduction are two tokens, re-induction. So tokens doesn't necessarily need to mean anything, right? They're just a combination of letters. So hello there, exclamation mark is 3 tokens. Hello there, an exclamation mark. Each of these tokens is represented by numbers. 9906, 1070, 4999. So what happens here is the transformer model will take these 3 numbers, just these 3 numbers, and try to predict what's the most probable 4th number. And it will predict that this is this number 13347, which means high. And then it will take this entire input of 4 numbers and will do this thing again. It will say, based on these 4 numbers, what is the most likely 5th number? And it will be 13. So that's it. At any given time, the model is not really aware of the end response it will spit out eventually. It's just able to figure out the next token, not even the entire next word, maybe just a part of the word, right? So if you have seen this typing is not actually a fancy animation. This is actually ChatGPT determining token by token the response. The typing is not there just to look fancy. It's actually the process of generating the response. So the question is, you could ask yourself, wait a minute, if this thing is just predicting the next word, how can it appear to be so smart, right? And the best analogy on this I heard was from one of either Max Tegmark or Yuval Noah Harari in one of the podcasts, where they gave comparison of human and AI on one hand and birds and planes on the other. Bird is such a sophisticated flying device. It's extremely energy efficient. It's made of very light materials. Bird bones are different from other non-flying animal bones to become lighter, right? And it can change its body shape dramatically to take off and steer during the flight, right? But we managed to build a plane. We didn't create such a device sophisticated as bird. We actually created heavy, rough around the edges, rigid device. But the thing that we added is a huge engine that is thousands of times more powerful than a bird. And that thing flew. So with AI, yes, it can answer. Yes, it appears to reason and responds like a human, but it has been trained on the entire human knowledge. The amount of data used to train the current AI to achieve this level of apparent smartness is just entire human knowledge, right? In contrast, we humans can talk and reason and appear to be smart, even if we haven't read every single book written by humanity. Our ability to learn from limited amount of information is not yet surpassed and not even close. AI is not even close to it. So let's try to go back to skills, right? But to understand which skills we need in the era of the artificial intelligence, we need to access our capability, our own capabilities, and how we think and compare this to AI capabilities, right? So I'll use the classification made by Professor Daniel Kahneman in his book, Thinking Fast and Slow. I know that you might find this book in the popular psychology shelves, but it's a serious thing and from a very serious author, a winner of a Nobel Prize. So Kahneman says that we have two systems of thinking, system 1 and system 2. System 1 is fast, automatic thinking. System 2 is slow, effortful thinking. System 1 is automatic, frequent, emotional, stereotypic, subconscious. System 2 is slow, effortful, infrequent, logical, calculating, conscious. System 1 handles everyday decisions, first impressions, intuitive reactions. It operates effortlessly and quickly with little or no sense of voluntary control. Examples of system 1s are recognizing face, understanding simple sentences, or driving a car on an empty road. System 2 makes complex judgments and decisions requiring attention and mental effort. So system 2 is used to solve difficult math problems, to focus on particular voice in a noisy environment, or to plan a complex itinerary. All right, so let's think about this. Can you understand when you use system 1 and when you use system 2? Let's try this. I'll give you a set of tasks. Try to solve each task and try to understand which of two systems you used. System 1, fast thinking, or system 2, slow, effortful thinking. Let's go. Okay, what's 2 plus 2? That's easy. It's 4. You knew the answer right away as any elementary school kid, right? You didn't use any effort to think about it. This is system 1, right? The next one, what's 7 times 8? Again, multiplication table is learned by heart in elementary school. Everybody knows it. It's 56. No effort. That's system 1. What's 25 times 25? Now, this is where it starts to get interesting. If your educational background involved some degree of practicing math and solving mathematical problems, there is a chance that your multiplication table is surpassing just single-digit numbers, and that you know by heart a lot of combinations of multiplying two-digit numbers. So for me, this is a system 1. But for example, if you would ask me 26 times 26, that would require some additional effort for me. For some reason, I know squares of certain two-digit numbers by heart. Okay, the next one. What's 17 times 37? This is definitely system 2 for me. I cannot just tell the answer right away. I need to think about how I would do it. I'll, for example, multiply 40 by 17, because this is closest to 37. And 40 times 70 is 680. Then I will subtract the 3 17s that I added above 37. So 3 times 17, 51. 680 minus 51. This is 629. That's system 2, because I had to put some effort into calculating this. The same thing for this division. And the funny thing is, For this division and for the previous multiplication, if you're a mathematical savant, if you have born with the natural ability of certain kind, or if you use advanced calculating techniques, you could transition these calculations to be done by System 1 to actually just instinctively, effortlessly answer these questions. Final task, what is the best move? Assuming you know chess rules, and assuming that you're not a highly ranked chess player, you would need minutes to solve this, and even then you might not get the right answer. However, the chess grandmaster will instinctively know the strongest move here. The chess grandmaster will use System 1 thinking to solve this problem. Now, how can we be sure that chess grandmaster or a skilled calculus person is using System 1, not System 2 for appear to be a hard task like the rest of the people? Well, turns out there are physiological phenomena accompanying System 2 thinking, like increase of a pulse, dilatation of pupils, rise of a body pressure, blood pressure, and all of this can be measured, and these experiments have been done. And what we have learned is that it is possible to learn certain skill so well that it becomes automatic execution by the System 1. All right. So still, there are some skills that are hard to impossible to be acquired by the System 1. And we'll talk about those skills later. As you imagine, creativity, acquiring new knowledge, and so on, critical thinking, these skills are hard to be acquired by the System 1. They require you to think. They require you to put effort, right? So in this Venn diagram, I illustrate this, right? Some of the skills that are, some of the skills that are typically requiring System 2 thinking, if you train enough, you will be able to execute them using your System 1, using this instinctive thinking, right? Why is that important? Well, if you look at the AI today is good at skills requiring System 1, but not quite there with skills that require System 2. How do I know that? Well, I don't really have a research backing this, but this is strong feeling based on my experience with AI. I believe it's a really good subject to be researched. But for now, let's assume this is correct, because we know that AI is good in recognizing faces, recognizes what's shown in the picture, handwriting, and similar tasks. And we know that generative AIs are slowly breaking into the System 2 type of thinking, right? Okay. So the important thing is AI will help us with all the work that requires skills of the System 1. And AI is not yet able to replace human skill that requires deep thinking, effortful thinking done by the System 2. Which lead us to two categories of skills that we will need for the AI-shaped world. We will need skills of using AI and technology in general, and we will need those skills to replace our System 1, and we will need it as an aid for System 2. ChatGPT can be helpful for you to reason, right? It can give you ideas. It can maybe validate some, or actually appear to validate some of your idea, right? And then there are system 2 exclusive skills that AI will not be able to match very soon. Now, let's not forget the first slide, that technology is moving and it's hard to predict the future. So, I believe, and the previous speaker, Milan, believes that we're very, very, very far from AI replacing our deep thinking. So, skills in using AI, again, a couple of categories here before we end up talking about the actual skills. First of all, let's talk about how can AI help. Obviously, AI is really good helping in coding, right? Then AI is nowadays good in generating content. Images, text, videos. There are social media profiles with a lot of followers whose content is generated mostly by AI. For example, all illustrations in this presentation are made using DALL-E. So you can get help with generating content, right? It can also help you with comprehension. You can summarize large documents using ChatGPT or Copilot. You can ask questions about certain topic or a document, or you can ask the content to be simplified to your knowledge level. If it discusses matters outside of your profession, right? You could ask the ChatGPT, hey, could you simplify this for me? I'm not medical professional, but I would like to understand this text, right? And it will try to do it. Finally, all the other applications of AI I put under the category of automation, not because it's the best thing to do. I'm just thinking these three categories are relatively new. All the other ones like classification, sentiment analysis, and others are something that is quite known. Now, skills needed to use the AI. Two categories again. You need to raise awareness and ability to learn AI tools. I mean, we have heard some terms. We have heard terms like Mistral, like LLM, like Transformer. So if you want to be somebody who's creating an AI-based product, you need to get to that to understand those terms and to be able to follow presentations of this kind, right? So getting informed is important to learn AI capabilities, but getting informed is also important to learn ethical and regulatory considerations of the AI. Why is that important? Obviously, there are a lot of concerns around the proper use and capabilities of AI, and there is already this EU AI Act, and there are other initiatives to somehow regulate the AI. So this is something to be aware of. Technical skills. There are a lot of skills related to AI. We will just mention prompt engineering, and we will mention some advanced skills. So regarding the awareness, light sources, you can easily get informed about AI from regular news outlets because AI is such a hot topic, so you will find all the news there. But you should also try to find some specialized news outlets. I like to follow some social media profiles like this guy here. I'm not affiliated with this person at all. I don't know this person, but I admire the fact that he uses his system 2 thinking to extract the most important news about the AI and to serve it to me, and I gladly accept that. Then there are these, I call them hardcore sources, Hugging Face, where you will find open source models. And if you would like to read the research papers related to AI, you go to EURAXESS, and you will find different categories there: AI, machine learning, and NLP, computer vision, and so on. Right? Related to ethical and regulatory awareness, Responsible AI by Microsoft is a very good framework regulating, or actually trying to govern the ethical aspects of responsible AI. However, there is also EU AI Act that I have provided a link. I'm not sure if these presentations will be shared. You can reach out to me, and I can give. This is a very good cheat sheet related to EU AI Act. The good thing about the EU AI Act, it's very easy to understand. It defines the kinds of use of AI and key requirements for each of the kinds of use. Why is this important for this presentation? If anybody here will work on a project related to AI or have a startup to build a company that uses AI or builds AI, and needs to understand this, because penalties for not meeting these requirements are up to 7% of the global turnover. Technical skills. Well, building and integrating AI systems, we will not talk about this in this presentation. This requires extensive training, a relatively steep learning curve, right? You would need to become machine learning or data science expert. Nowadays, with models such as GPT, such as Mistral, that are very good at what they do, often we see a demand for something called AI engineers, people who understand AI, who know the models, who know the possibilities, but are also good as software engineers and are able to integrate AI in other systems. Simple AI use case that I will show in the next slide is prompt engineering in ChatGPT. If you want to go a bit above that, you need to go to Hugging Face, download and try some model. Often, models in Hugging Face are accompanied by application that you can use to test the model. So, prompt engineering. What is prompt engineering? It's designing and refining prompts to effectively communicate with AI models. Let me remind you what GPT, what large language models do. They actually are completing the previous conversation. Well, knowing that, it turns out that it is possible to ask the question, to create the prompt in a way that gives a better answer. So I have included the link that actually gives you all the kinds of prompt engineering techniques. But in the next slide, let me show you a couple of those. The first prompt engineering is called few-shot learning. Pretty much, it means that with few examples, you can teach AI how to respond. In this example, I want to answer only questions about football, and I give examples of how to answer those kind of questions and how to answer any non-football related question. So if you're using ChatGPT, just typing in ChatGPT, this may not be the super useful example. However, if you're building chatbot using the API of ChatGPT or Azure OpenAI or Mistral, then this is something that will be useful and that you will most likely do to direct chatbot into providing certain kinds of answers. Another example is called chain of thought technique. Remember, the transformer model, because it only completes the previous conversation, well, that has one implication, and this is that if you ask it to think about own steps when answering, when generating answer, because it's answering step by step, the previous steps will improve the following ones. So here is an example without chain of thought. If you ask it, hey, what will be a cost of camping trip for 2 persons for 1 week in Costa Brava? I live in Berlin. Pretty much it will provide an answer. This is actually from one of the LLMs. It's not able to answer that question. But that's not really possible because let's remember that LLM is trained on the entire human knowledge, right? So it should have a rough idea at least about the cost, right? So if you just add the explain step by step, then it will actually trigger AI to think of first step, which is transportation, and then the next step, and the next step, and finally it will include the total cost. So these prompt engineering techniques are useful if you're just using the AI chatbots like ChatGPT or Copilot for your regular work, but are even more important when you're working with building some sort of technology on top of the AI model. Finally, human-only skills are very important to be considered because this is something where AI will not be able to replace us in the anytime soon, and these are complex decision making, creating problem solving, learning new concept, critical thinking and evaluation, adaptation to novelty, and some highly technical and specialized tasks. Why some highly technical and specialized tasks? Aren't they done using System 1 only? Well, some of those still do not have AI replacement. Some of them include manual labor, and some of them combine other skills stated above. For example, if you're a neurosurgeon, you are very skilled with your hands, but you need to do complex decision making. You need to constantly learn new concepts, adapt to novelty, pretty much all of the above, right? So there are skills that we could imagine that are easily replaceable by AI, but for regulatory or ethical considerations, or that we just don't feel like it, we don't feel comfortable that AI does the work of a human. These skills are not replaceable yet. These are skills of lawyers, some of the medical specializations, bank credit advisors, pilots, and so on. How do I obtain and use these skills? To become good in skills not replaceable by AI, generalization is very important. Learning, reading, work hobbies, not getting stuck into narrow profession, or if you must be in the narrow profession, then having hobbies in alternative areas. Finding a way to expand the applicability of your judgment, reasoning, and creation skills is a way to go. Finally, how do you use both of these skills? The skills of knowing how to use AI and the skills that are not replaceable by AI. Well, first of all, you should automate repeating work. With AI, there are much more abilities. then learning subjects that expand the system 2 area, as we mentioned. And finally, collaborate. Collaboration is yet another powerful skills that humans are extremely good at. And with responsible AI aligned to human values, hopefully we will also soon have the opportunity to learn how to collaborate with AI. Thank you for your attention.